Hi guys. So what we're going to do today is we're going to transition from absolute value equations to absolute value inequalities. So we're going to use some very similar strategies, but we're going to really have kind of one extra piece that we need to consider. So what we're going to do here is we are going to start by looking at the graphs of these inequalities. And that's just really what we talked about with equations. Really every equation is just saying what's the intersection of those two things. So I want you guys to see visually kind of what's happening when we solve this inequality. So the first thing I'm going to do is I'm going to graph the left side of this inequality. The absolute value of x minus 2 minus 1. That's an absolute value function that's shifted right 2 and down 1. Has a slope of 1. So my graph is going to look something like this. I want to know when that graph is greater than or above the line y equals 2. So there's the line y equals 2. So I can find the intersection. But my solution here, since it's an inequality, I want to know when is the blue graph above the purple graph. And you'll notice there's two regions. This part over here and this part over here. So I can write this two ways, inequality or interval notation. We'll go ahead and start with interval notation. So left to right, I'm listing the x values, again, where this is happening. From negative infinity to negative 1. It's a parenthesis because the question was not or equal to. And then it picks back up from 5 to infinity. In inequality notation, I would have two inequalities. I could have x is less than negative 1, and I have x is greater than 5. All right, then looking at the next one. Again, let's go ahead and graph the absolute value first. So this has been shifted left 1 and up 2. And I want to know when that is less than the line y equals 3. So where it's below that is right in that little region. So it's a real small area this time. Again, in interval notation, that would be from negative 2 to 0. In inequality, I would have negative 2 is less than x is less than 0. So what I want you guys to see here, what's really important to understand, is that we're really creating two equations, just like we did for solving equations. But how we set those up is going to be different based on what your inequality is. There's a difference between the absolute value being greater than a number and the absolute value being less than a number. So if we're looking at a case where we get the absolute value by itself and it's greater than a number, we're going to set up two equations, but we're going to say or. Okay, one of these situations or the other situation. Very similar to this first one. Okay, my solution could be in this region or in this region. If we have a case where absolute value is less than a number, then we're going to use kind of that compound inequality, and we're going to call that an and situation. So we're looking for where x is less than 0 and x is greater than negative 2. So kind of the overlap there, which is just this region down there. So once you get the absolute value by itself, we kind of have to remember, again, it's kind of how I remember it, it's greater and less than, I far out my T. Okay, greater and less than. All right. So let's go ahead and look at some of these algebraically. All right. So on this first one, again, first step, just like it was for solving absolute value equations, you have to get absolute value by itself. Do not make any decisions until that absolute value is isolated. So add 7. Divide by 3. And now we can make our decision and split this into our two inequalities. So we're looking at absolute value greater than a number. So equation number 1. And then equation number 2. Now the way we do equation number 2, again, there's two different methods you can use. It's a matter of what you're more comfortable with, how you want to see it. Now, the way I'm going to do it is similar to how we did equations. I'm just going to change the signs and basically negate the absolute value. Now, if you don't do it that way, what you can do instead, if you just want to change the sign of the right side, you can. However, you can't just do that. You also need to basically flip your sign. Because what you're really doing here is you're looking at the negative version of this function. And when you do that, when you divide by a negative, it flips the absolute value sign. So you really have x plus 1 is less than or equal to negative 2. So if you change the sign on the right, you have to flip your sign as well. So what I'm doing instead is I'm just flipping what was inside the absolute value and keeping the sign the same. Again, both methods will work. You just got to be, whatever method you go with, you got to stick with it the whole time. And that's really the important thing here. All right, so let's go ahead and finish solving this. So x is greater than or equal to 1, or I've got negative x is greater than or equal to 3, x is less than or equal to negative 3. Now with these, we're going to write our answers in interval notation. If you can find your interval notation from this step, great. But what I usually recommend is graphing this on a number line, just because it makes it a little bit easier to see visually and helps to make sure we didn't make some sort of mistake somewhere. So here's negative 3 and here's 1. So I'm looking for where x is greater than or equal to 1, and I'm looking for where x is less than or equal to negative 3. Since this is an OR situation, we don't need to worry about any overlap. We're just finding where we drew our arrows. So from negative infinity to negative 3, with a bracket because it's or equal to, and then bracket from 1 to infinity. All right, looking at the next one. Again, before we make any decisions here, we need to get that absolute value by itself. So I will subtract 6. When I divide by a negative, I flip my sign. Then I set up two inequalities. So inequality number 1, x plus 3 is less than or equal to 1. So we're talking about less than, so my second one is an and. So I'm going to do negative x minus 3 is less than or equal to 1. Again, if you want to do x plus 3 is greater than or equal to 1 or negative 1, that will also work. That will still give you the right answer, but this is just the way for me. I think it's a little bit easier. All right, let's finish solving. So x is less than or equal to negative 2. Over here, I've got negative x is less than or equal to 4. So x is greater than or equal to negative 4. So we'll go ahead and plot this out on our number line. So here's negative 4, here's negative 2. I want x to be greater than or equal to negative 4. I want x to be less than or equal to negative 2. And because we're talking about and, we want both those things, the compound inequality there, you want the overlap. So the overlap there is from negative 4 to negative 2. All right, so now we're going to look at a couple different cases. So let's start with this first one. Again, first step, get your absolute value by itself. Okay, so now at this point, what we're dealing with, we're looking for where the absolute value of 2x plus 1 is less than negative 5. Well, let's think about this for a second. Absolute value, we know, has to be a positive number. Positive numbers are not going to be smaller than negative numbers. So if you can recognize this, once you get the absolute value by itself, if you recognize that you've got a negative number on the other side, you've got a lot less work to do. At this point, you can realize, hey, this is never going to happen. There's no solution. All right, you also, again, we can look at this graphically. Let's take this original function. Okay, this graph has been shifted left, shifted up, stretched a little bit, so something like this. I want to know when that graph is below the line, y equals negative 1. Well, that doesn't happen. And let's say we didn't even realize it. Okay, let's say we just went ahead and solved this. Okay, let's go ahead and solve it. 2x plus 1 is less than negative 5. So 2x is less than negative 6. And x is less than negative 3. All right, let's solve the other one. Negative 2x minus 1 is less than negative 5. So negative 2x is less than negative 4. X is greater than 2. Since it was less than, it's an and situation. So I'm looking for the overlap where x is both less than negative 3 and x is greater than 2. So there is no overlap, okay? There's nothing there that actually overlaps. But again, save yourself the time, guys. If you can recognize from the start that you have an absolute value by itself and a negative on the other side, stop there, okay? There's no solution. Now, just because there's a negative on the other side doesn't mean there's no solution. It just tells us to pause and consider what we have. So let's look at this next one. Let's get the absolute value by itself. All right, now it's greater than a negative. Well, when we're talking about greater than a negative, a positive is always greater than a negative. So in this case, we can again stop, but this time my answer is all real numbers. if we want to write that in inequality, or sorry, an interval, we can just say negative infinity to infinity. So basically, get your absolute value by itself, like always. If the absolute value is less than a negative, there's no solution. If the absolute value is greater than negative, it's negative infinity to infinity. All right, again, two kind of special cases. Let's look at these next ones. Let's get absolute value by itself. All right, so at this point, we have absolute value greater than 0. Well, again, absolute value is going to be a positive number. So that's pretty much always going to be true. But it's not always true. There's actually one case where this will not be true. And that's because this equation does not say greater than or equal to 0. So what has to be true here, this cannot equal 0. Which means that x minus 4 does not equal 0, so x cannot equal 4. So if you want to write your answer that way, if we want to write it in interval, we can do that as well. But this one, again, kind of unique just because, yes, it's always true, but it can't actually equal. Now, if the original problem did say or equal to, then it would just be all real numbers, and you'd be good. All right, and then this next one, again, kind of a similar concept. All right, I divide by a negative, which is going to flip my sign. Doesn't change the 0, but flips the sign. So absolute value less than or equal to 0. Well, absolute value is going to be a positive number. It's not going to be smaller than 0. But it could be equal to 0. So there is actually one solution here whenever x minus 4 equals 0. So there is one place this is true, and that's when x equals 4. So those two are very unique cases. The negatives you would probably see more often, but E and F, again, those are just kind of some really unique kind of special cases. All right, let's look at these next two. Again, same idea here. I'll write absolute values are by itself. So equation number 1. It was less than... So I end up with my two inequalities. All right, I'm going to go ahead and graph this out just to see what it looks like. Make sure I didn't make any mistakes there. So I've got 2/3 and 4. So I'm looking for where x is less than 4. And I'm looking for x is greater than 2/3. And we're talking about the overlap. So the overlap between those two is from 2/3 to 4. We'll use parentheses because it's not or equal to. All right, and then this last one here. This one's a little bit, again, we kind of need to stop and think about this a little bit. So what we've got, again, an absolute value compared to an absolute value. Those absolute values are as isolated as they can get, all right? But what we know, whatever is in this absolute value, whatever we plug in, it's going to be a positive number. So I'm going to have -2 times some positive number. This absolute value over here is also going to be some positive number. Well, if I have -2 times any positive number, it's going to be a negative number. Some negative number. It doesn't matter what it is, it's going to be negative. And over here, I'm going to end up with some positive number. So we need to think, when is a negative going to be greater than a positive? Well, a negative is not going to be greater than a positive. So this graph has no solution. We don't need to worry about if they're equal because there's not an or equal to on our question. All right, and then finally, again, just considering a word problem here. I know, again, with these word problems, you can probably do these a lot easier without writing the absolute value equation and solving it, but it is important to understand what absolute value equation we can use, because, again, that's something you could see come SAT, ACT. So a machine cuts boards that are 3.25 meters long. The boards are not perfectly cut, so there's an allowable amount of air. Okay, so that air is kind of like we did last time, where we talked about how we had our midpoint and we had our allowable difference, basically. That's what we're going to have on the other side. So it says if the boards differ by more or less, they're thrown out. So what we need is the amount of air to be less than or equal to 0.02. So we take the length of the board, we subtract 3.25, take the absolute value, less than or equal to 0.02. Again, you can go ahead and solve this. I know you know what the answer is going to be without solving it, but it's not bad practice. So x is less than or equal to 3.27. And x is greater than or equal to 3.23. So in interval notation, our range of acceptable lengths would be from 3.23 to 3.27. Again, I understand you can look at this and figure out the answer, but we do need to understand how that corresponds to that absolute value equation, because again, that's something that could come back up for you guys. All right, so that is it for absolute value inequalities. We're going to transition into just some more generic function stuff for the rest of the unit.